Welcome back to Tutoring with Tiana. Today we are going to be talking about triangle congruence and some of the kind of more difficult, maybe confusing examples that you'll see as you go through this unit. I am just going to show you kind of the ones that stand out to me for the ones that like my students tend to struggle with and kind of go through what theorems you would need to know or need to use before you can prove triangle congruence. So let's jump in. Our first two examples are pretty similar to each other. I guess also something to note before starting this is sometimes you'll be given the information in markings, like on the drawing, on the diagram itself, and other times you'll be given the information in word form, and it's up to you to draw the markings in based off the information that they give you. So it's important that you understand the notation. Also, knowing the vocabulary is going to be really important because that is going to be like a barrier to understanding what they're saying. That being said, whenever you have examples like number 1 and 2, where you kind of have these crisscrossing triangles, the first thing that you should always think of is vertical angles. So we know that these are congruent to each other. Similarly, we know these are congruent to each other through vertical angles. And then if we're looking at example number 1, we actually have enough information to prove that these two triangles are congruent just with the information that we have. And so this would be triangle congruence through angle, side, angle, because the side is between the angles. For example number 2, we know a side, we know an angle. We don't have quite enough information yet. However, we do know that these two lines are parallel to each other, as indicated by the arrows. And while you're in geometry, whenever you're given parallel lines or it's indicated in the diagram, you would always want to think of your transversal theorems and the angle relationships that come from those. So if we draw a transversal cutting through these two parallel lines, you can use this line, you can use the other diagonal, you'll still get the same result, so it doesn't matter which one you use as your transversal. If we're looking at our transversal now, we know that these two angles are congruent to each other through alternate interior angles. And now we have enough to say that these two triangles are congruent through angle, angle, side. And again, I really want to emphasize the difference between example number 1 and example number 2. Number 1 was angle, side, angle because the side was between the two angles, versus example number 2 was angle, angle, side because the side is not the included side, so not between the two angles that you know. And of course, if you were writing a proof out, like you would have to write all of this information out. For example, number 1, that you know that these two angles are congruent to each other through vertical angles, that you were given two angles and two sides were congruent to each other. So you would have to like write all of this out. I'm just kind of going through, again, like common examples and then common tactics that you would use while you're going through these type of examples. Another similar types are 3 and 4. So anytime you have like two triangles that are like sort of connected to each other, they have this shared side. The first thing that you would want to think of is the reflexive property. So you know that this line is congruent to itself. And again, that's through the reflexive property. And if we're looking at example number 3, we have enough information to prove that these two triangles are congruent through side, angle, side. If we're looking at example number 4, there are a couple of ways that you can approach this. Just looking at the example, we actually do have enough information to prove that these two triangles are congruent, again, through side, angle, side. But if that didn't come to you immediately, the other thing that we should notice is that this larger triangle here is an isosceles triangle as indicated by these two markings. So we know that the base angles are congruent to each other. And so if you wanted to go that route instead, we could say that these two triangles are congruent through angle, side, angle. Okay, examples number 5 and 6 are also pretty similar to each other, but we're going to use slightly different tactics. Whenever you have these triangles that overlap each other, I would highly recommend that you separate them out first. So if we are looking at this triangle, we'll pull that guy out. And then if we're looking at this triangle, pull this guy out. And then they may or may not give you all of this information, but I kind of wrote in 2 examples of markings that you may see. So I'm going to give you 2 kind of scenarios that you could fall into. So first we can use the angles. So we know that these top angles are congruent to each other, and then one of our bottom angles are congruent to each other. And then by nature of the way that the diagram is drawn, we know that this bottom side is congruent to itself because it's a side that they share. It's their overlapping side. And so now if we're looking at these two triangles, we can say that these are congruent by angle, angle, side. Angle, angle, side. I'm going to redraw these two triangles. And the other scenario that you could fall into is knowing that these two sides are congruent and then that these angles are congruent to each other. But same sort of logic follows. Like they have this overlapping side at the bottom. So we know that this part is congruent to itself. And if we're trying to prove triangle congruence, now we can use angle, side, angle. So those are two scenarios depending on the markings that they give you in the initial diagram that you can use. I will talk about like a potential pitfall with this if you don't pick the right markings, or sometimes they may give you these markings and it's not enough to prove triangle congruence. So for example, if we were given these two triangles, and for instance, if we were only given that the top angles are the same and that these markings are the same, again, we know that the bottom side that they share is overlapping, so it's congruent to itself. You may think that this indicates triangle congruence, but it actually does not because it falls into side-side angle, which is not a triangle congruence theorem. This is side-side angle. So this does not work. These are like the three examples that you could fall into. The bottom two that we talked about actually do prove triangle congruence, but if you're only given that the top angle and one of the sides is congruent, you may not be able to prove triangle congruence, especially if you fall into a case like the last example that I just provided to you. For number 6, again, we're just going to start off by drawing these two triangles separately. Their hypotenuses are congruent to each other. Sort of the same logic as the previous one. We have this overlapping side at the bottom, so we know that that is congruent in both of these triangles. And because these are right triangles, we can actually use the hypotenuse leg theorem. Okay, number 7, arguably one of the most confusing examples that you can run into. Let's see what we can do. First up, we will again split these two triangles, and then we know that these are congruent. The other thing that we know is that this side is equal to this side. I'm actually going to do 3. And we know that because this segment is congruent to this segment, this segment is congruent to this segment. So we know that those lines, BE and DA, are congruent to each other. The other thing that we know for this type of example, if you notice, there is an overlapping angle at the top. We have this overlapping angle C here, but we know these two are congruent to each other. And these would be congruent through angle, angle, side. I hope it was helpful. Let me know if there's anything else that you guys want to see or anything I could do better. If you wanted me to like write the entire proofs out, let me know and I will see you on the next one. Thanks. Bye.